Okay, hi there. So welcome back. So by this time, we already have our HEC-HMS model ready, the rough model that we have created in the last tutorial from DEM. So we run the model for very rough condition. We created that precipitation time series, right? It was not correct. So what we have to do now, because I created that one for the sake of running this model, but now what I'm going to do, I'm going to even create the input files for that study area, right? So we have to check how many stations we have. If we have any observed data for each of this basin, then it's good. Or we have to even create the basin average precipitation for gridded data set. So we can even use NLDAS data. So I already have a video how to download NLDAS data set. And for the year 2017, we can use even the most recent and updated precipitation product that is called MRMS, multi-radar multi-sensor precipitation. That is also in netcdf format. So I have a script in R programming language, so that can even convert that gridded data from gridded data set to basin average. So if I pass that shape file, so it will give you that basin average time series. And I can prepare that basin average using model builder in ArcGIS as well. So let me quickly share my screen and show you how to process. I'm just starting from downloading this precipitation, and we also need the time series of streamflow, right? I already demonstrated how to download USGS streamflow time series daily data. So today I'll show you how to even download this 15-minute interval data. I have that script, so you don't need to even copy and paste and import into Excel sheet and do this and do that. You don't need that. So I have the code. I'll show you that how to download at once. It will just quickly download the text file, and I have another script that will convert that text file to right into time series. So let me quickly share and show you what is the next step. So by this time we have this model, right? So if you are already done with this one, so you are lucky and you can even proceed with me. Maybe I'll show you in the next tutorial that how to even estimate the other model parameters. So today I'm going to show you how to download the meteorological and hydrological data, right? The precipitation and the stream flow. So what we have done here, we selected 3 gauges, right? One is here, another one is here, and another one is there. So these will be our stream flow location, even though we have many stream flow location, but since these stations are at the outlet of this subwatershed, so we can even compare and we can calibrate and validate our model at these stations. But we have to even provide the precipitation for each of this subwatershed. So for the time being, what we can do, we can download both dataset, netcdf file of NLDAS, and then we can even download that MRMS. I'll show you that both. And for the time being, since we are going to calculate the basin average, I'll show you that even not today or in the next tutorial maybe. But for the sake of running this model, I'm going to show you even other process as well. If I select one time series from each of this subwatershed, even we can use that as well. Okay, so I'll show you that. Let me just show you the map of this subwatershed in GIS. So I'm also working on this GIS, right? So you can see these are the GIS-CN stations. I already even demonstrated how to download GIS-CN data. These are basically a global historical climatology network. You can find this station anywhere in the world. I have already uploaded that video. You can watch that if you want. So out of these many stations, I need only one station, right? If I have this, these are basically the observed data, gauge data. So I have the script in Python that can process this and create the time series. So what we can do, we can even select. I'm showing different options. You can just adopt one of them, okay? You don't need to even follow all of this. So the main idea is to calculate the basin average precipitation. See, since we have the observed data, if we select this station and if we assume that, okay, this station represent the basin average for this, okay, then we can use that. Or we'll use our gridded precipitation because that is not the point gauge or something like that. So it has different types of grid, and like that, if I show you how to Okay, let me show you that draw. So if we even download that gridded data, okay, we have a grid like that. We'll download that shortly, NLDOS and MRMS precipitation. So what we are gonna do, and we have this grid X, okay, from north to south, this will be our gridded data. So out of this grid, we have to calculate the basin average, okay? We have to calculate the basin average data. Okay, that's it. So we'll calculate one value for this subwatershed from this grid, right? So, and one value for this subwatershed, and from this grid, one value for this one. So I have the code and it will calculate that one. So that is another step. I'll show you that one as well, not a problem. So as a next step, or for this tutorial, what I'm gonna show you, I can even select one station, right? If I have the time series, I don't know, I can extract, I can select one. Okay, for example, I'm gonna selecting this one, okay, this station, and I'm considering, okay, this station will represent the basin average for this selected sub-basin, and this station will represent the time series or basin average for this one, and this station will do that. So for here, see, we don't have any station in the middle of that one, so we can even consider any of them, okay, this one or anyone. Or for this one, it will be representing this one, and this one will be representing this one, so we don't have anything there, so we can even select close to any station, this one, right? Or even we can use the same time series for that one as well. It is not a problem. And we can even select this one for this one, right? So that is one step. We can create that time series. So in order to do that, we have to select those stations, right? We have to select those stations. So I already selected that one out of this many. I selected how many stations I have within that, because I already demonstrated that one in my GIS tutorial, right? How to even select a feature within our model boundary. I already demonstrated that one. We have to go to that selection and select by attribute or select by location. For this case, it will be select by location. And if you select that GICN, because that is the station that is covering the entire globe, and if you just select that, if you pass the outer boundary, and if you select here completely within the source layer, then it will select everything, and then you can right click there and export, and it will be giving you these stations, okay? So I think that's okay that you understand that. So what is the next step? So next step is to create a CSV file, right? We have to export these stations. We have to export these stations as a time, the CSV file. Then we'll use that CSV file because it will give you the latitude and longitude. Let me check that if we have the latitude and longitude, otherwise it on. Yeah, we need the name for this case. Okay, I'm opening the table. Yeah, we have everything there. See, we have the station name and we have latitude, longitude, everything is there. So we can even select first, right? Select first, and we'll check if we have the value. I don't know if the value for all of them exists or not, because we have many stations, and which one we are going to select and which one will have complete time series for the year 2017 or not, I'm not sure, but I'm going to show you that one, and let's see, because it will take very quick time. So GICN, because I already selected that one, so for the time being I selected these stations, okay, and then I'm exporting this one. Go to your ARC toolbox, and I already added this table to CSV, and if I double click there, so it will give you table name, which one, so that will be GICN HEC-HMS, okay, GICN HEC-HMS, and it will save everything there. ArcGIS tutorial lab, no, I'm gonna save it to my HEC-HMS, because this is HEC-HMS, right? So let me save it there, so it will be convenient for us to follow. Inside HEC-HMS, I can even save that one, okay, GICN HEC-HMS. These are the GICN and for HEC-HMS model, GICN stations, okay, it will be there, and it's already there. Let me quickly check that. Maybe it's there, HEC-HMS. where it is. It should be there. Okay, HEC-HMS, and it's there. See, if I open this one, we'll use this list. We have 10, right? We already mentioned that, and we have 10 stations, and 10 station each of them is for one sub watershed. So we'll use this station name to create time series from GISN. I already mentioned that one, how to download GISN data, and let me open my Linux machine. So I already demonstrated that, so you can go back to that videos. These videos are there in the download playlist, and I already demonstrated in details how to download all of this. So since I already have this data, so I can use those data set here pretty easily. Yeah, let me find that. And this time I'll also show you how to download this time series of streamflow from USGS as well. So I have this station. I have to put this station here, GISN HEC-HMS. So let me check that it is there. I already uploaded that one, so it's the same stations I selected. It's there. Okay, so these are the station. I uploaded that, and let me show you the script I have. Okay, GISN precipitation. Here is the script. You can see because I have the data. See, GISN all the data I downloaded. You can go back to the previous videos, so you can see that. So let me show you where I have. So GISN. So I have everything. I have the data for all of USA and for the entire world. So it will select only these stations. So it is taking too much time to even expand because this data is huge. So by this time, okay, it's expanding. I'm showing that I'm reading this data, and I'm just creating the time series by this name. Okay, GISN data sends us into HEC-HMS. And I think I already have, see, these are the daily data. These are the text file. We can't even read this one. So if I open one file, you'll see it is kind of difficult to read. These are the data set. Sometimes it is missing. Sometimes there is nothing like that. So out of this text file, we can't even see what is there, right? And we'll create the time series. So I'm gonna save this inside that folder because I tried that one. Let me delete that one. GISN HEC-HMS sends us into this one. Okay, I'm deleting this folder because I created that one. I'm deleting that one, and I'll run it again. So it will save everything there. I'm reading this station names from this CSV file I just created. I just converted from from ArcGIS to CSV, those stations, and it will give us the time series. Let me just run the code, and it will give you that. So since it is Python code, so it will be GHCN. Okay, GHCN. What is the name of passive extraction? Okay, passive extraction time series, station time series. So it will quickly give you that. It is reading that and everything. See, it's giving us the time series. It is in millimeter, and it's showing us the. Yeah, if I just switch my window. Okay, if I switch my window, it will show you that what we have in the other side of the window. Okay, I can even show you that. It's pretty quickly plotting. It's pretty quickly plotting. You can see that. Can you see that? Okay, let me. Oh, it's already done. It was showing the precipitation. Not a problem. Go back to our folder where we have this data. GISN HEC-HMS, this one. So you can check the time. It's time. See, now it just created. So for each of this, maybe we have some missing precipitation data. So for this one, this station, let me check that because it's showing. See, we have this data, not for the complete, right, from 2008 to, because we need this data for 2017, but we don't have the data for this station. So these are the demerit. If you select, so I don't like that. So what I'll do, I'll download that MRMS precipitation. See, we have this data from 2008 for this station. So this is kind of hassle, right, to check and click. See, this, we have the data from 1921 all the way to 1956. So we don't have this data. So we have to check which station has data or not. So I'm not gonna use that. This is one option we can check. Definitely there are some stations that has this data. Next, let me finish that downloading precipitation data. So what we can do, we can download NLDAS data. So how can we download NLDAS data? I have this video. We can even watch that. So the main step is to, let me show you that, NL DAS, okay? NL DAS. So here, NL DAS Preciv. NL DAS precipitation, we can search and we can go to NL DAS this way. Let me find the exact, because I already mentioned that how to download and how to even, yeah, so let me find that specifically. So that is the station we can go, and we have to select the time because we're going to download this data from August 22nd to, so that is the specific link. If you want, I'll even give that link in the description below. You can go to that link and close. So you have to open one account because this is from Earth's data. This is basically from NASA. So we can select here. See, we can make subset of this data set, and we can select the options, different variables as well. So which one I'm gonna do? So original file, no, I'm just gonna select the subset of that, and then the range of the data. So it will be like, we have data for a long time. It is only for 2017 and from August 22nd, okay, August 22nd to 2017 September 10, okay, September 10. So is that correct? Definitely. Okay, so this is the date range. It will give us the URL link, and we'll use that URL to download our data, and we have the options here how to download. I already demonstrated that one, how to download this in Windows and in Linux machine. So you can go back to that video and check. If you're a Windows user, so it's covering the data for entire USA, not a problem. Even we can make subset. I already mentioned that one. I'm not changing that. So the variable you have to select, this is the APCP. These are in kg per meter square, means it is in millimeter. And I can select that APCP. This is the precipitation. If you want, yeah, for the time being, I'm selecting short wave, long wave, evapotranspiration pressure, and this specific humidity. We'll use that to calculate relative humidity, because if you want to use any ET module, right, for example, if we run the model for long period, we can use SMA, right, soil moisture counting module for loss method, and we can use even evapotranspiration module now from Penman-Montet equation. We can use that. And grid format, okay, I'm not going to download the grid data. That is basically the gridded binary. That's a grid. I'm going to select that net CDF. Even we can select that geotiff. We can even geotiff, we can open that geotiff in ArcGIS. So I'm going to select net CDF file. Okay, if I use get data, it is just creating the link or URL. It will give us the URL, and then we can use, and it will also give us the instruction. See, we have the instruction for downloading this data. We already have the URL. We can download the URL. Here is the URL. Okay, so I'm saving that in my download. I'll show you in Windows, because in order to download this data, we need that wget. I already provided the link in the previous video, how to download NL DAS data. You can check that, how to download this executable. So here is the instruction. If I click on that download extraction, or there we get, it will give us the link. Okay, so we have Windows option, we have a Linux option. So let me just quickly create a folder where I'll paste this file. So what it is giving, I'm quickly showing because I already have that. Okay, I'm opening that using my editor, notepad editor. See, we have this link. So if we use automatic system, otherwise you have to click one by one. If we click one by one, it will download. So it will start downloading thing. We don't need that. Okay, we want everything at once. So I'm copying this, and I'm going to create here, basically not here, inside my, okay, since it is easy to create, download, and then NL DAS. Okay, NL DAS, and it will be Harvey. It will be for Harvey. Okay, I'm putting everything there. So we have to even put the executable from wget. How can we get it? So I think it's already there. I downloaded that one as a zip file. Let me find it there. wget this one. Okay, I'm expanding it, and I'll copy the executable and I'll put it there. Extracting yes to all. Yeah, maybe I already have that. Okay, so let me find that this one. Okay, I have this executable. Copy that executable and go back to download and put everything inside that folder. Okay, now we have to go to this directory, open Windows command, that black screen, and write cd and paste that link, and then it will direct to that directory here. Okay, and if you want to see what we have inside, so we have that file. So let me just copy that command from Windows. If you want to download one file, we have different command. If you want to download this all files together from a text file, you have to follow this one. Before that, we have to create this thing. Okay, cookies and everything. We have the options here. You can go to this website. I already mentioned that one in my previous video, so I'm just quickly passing that. So here it is. I already have my IDs and password. You have to open one ID and password to log into their system. So that will be subset. Okay, so I have the text file. What I have to remove now, yeah, it will ask password. So I have to provide my username here. My username is this one, and I'm passing that. Okay, ask the password, then I'll give the password. Okay, so if I press enter, it will ask the password. Yeah, so I'm giving the password. Hopefully it will work. Yeah, it's working. See, it's started downloading this data set. Let me check if it is really working or not. Yeah, it's working, and it's giving us the netcdf file. Okay, this is the netcdf file, and if I want to see what we have inside that netcdf file, I can quickly show you that one file. So from this netcdf file, we'll calculate the basin average, and at the same time, now we'll even download that MRMS data, and we'll even export the time series quickly. Even we can export from this one as well. Okay, so I'm plotting now using Panoply. I already demonstrated how to plot using Panoply in separate videos. It is in the plotting list playlist. You can even check that. I started that tutorial, but still I'm working on that one. So here is the data link. We can even open one file, and let's see what variable we have. See, we have all these variables, precipitation, we have even others, right? So I'm gonna even open this one, and let's see the spatial extent of that. See, it is covering the USA, entire USA, right? And where is our model? Our model is in Texas, right? It is there. It is there, somewhere there. Okay, so it is somewhere there. We can import that. So that is the precipitation. So I'm not gonna show that in detail. So once this download will be done, in the next tutorial I'll show you how to create basin average. But now let me download that MRMS data. Okay, MRMS. So I'm going to my Linux machine again, and then how to download MRMS, right? So let me find that if it is there or not. If it is not there, maybe I have to go back to another session, and let me find that it should be there, and maybe it is yeah. So I was creating everything for Del 3D model, that's why I have this one. And if I just go to my script, so probably it will be there. Okay, so find that MRMS, how to download that. I already demonstrated everything, how to download MRMS using your Jupyter notebook, or you can use Spider. So I'm doing everything there. Okay, so that is the convenient way I have MRMS download. Okay, download MRMS. Let me find that, if it is there, or if it is okay, or in my other machine. Let me find it where it is. Okay, because I have many. It is not there. Oh, okay, wait. So it should be stage 4 data set, and this. We have different options to download this data. I have written one code that can even download everything at once. It is gonna take a while to figure it out where it is. Okay, if it is not there, maybe it will be somewhere MRMS. So I downloaded this one. Okay, it is this one, MRMS precipitation, and let me go back and find that. It should be inside that general script or NWM Galveston Bay Inlet. Okay, it's different one. I also have that in my Windows as well. MRMS. Okay, I created that link. Let me find it there. Maybe it's there. If I open one Jupyter Notebook. Okay, let me open Jupyter Notebook again. Then CMD, and let me activate my Python environment. That is this Python environment. Okay. Oh, then I'm activating that Conda environment. Okay, and then I'm just calling Jupyter Notebook. So it will open Jupyter Notebook, and then this script will be activated. Let me check if I have the script already there. Then it will be convenient to see. Let me show you that. Hopefully it is there, or this is not that one. Okay, that is the home, and I think I had, maybe I just deleted that one. I don't know if I already deleted that one or not from download, or it was there in my document. Where it is? Where is the? I had that, maybe because I already saved that in my Linux machine. I already have that, so I can figure it out. Not a problem. Okay, so we are done with GISCN. Now we are focusing on our. Let me quickly find it here. It is better to find other than finding from this one, MRMS precipitation. Maybe it is not here. I'm pretty sure it is not here. It should be. If it is there, it is convenient. Maybe it is there. MRMS, download MRMS. I have this, but this is basically a different one. It is not the one I want. And then, yeah, I'm coming back. I'm finding that one, and I'm coming back. Okay.